Go ahead and try this do now on your own. Draw as many arrays as possible that have 12 total counters. I did an easy one for you and did a 1 by 12 array, which does have 12 total counters. Now I want you to create as many different arrays as you can. When you're ready to see the answers, press play again. Welcome back. Hope you had fun drawing some arrays. Take a look at all these possibilities. So you could also have drawn a 12 by 1 array. We sometimes call these a turnaround fact, right? 1 by 12, or you just kind of flip the array to get the 12 by 1. You could have had a 2 by 6 array, or the turnaround fact, a 6 by 2 array. You could have had a 3 by 4 array, or the turnaround fact, a 4 by 3 array. Let's take a look at all the multiplication facts we've come up with that are equal to 12. So we have 1 times 12 equals 12, or 12 times 1 equals 12. We have 2 times 6 equals 12, or turn around, fact, 6 times 2 equals 12. And finally, 3 times 4 equals 12, or the turnaround, 4 times 3 equals 12. Now let's go back and label these equations. Remember, they have an equal sign, so these are equations, using the terms factor, product, and factor pair. So the factors in a multiplication problem are the numbers being multiplied. Let's go ahead. We'll highlight all our factors yellow. So the numbers being multiplied are the factors, right? These are all factors because they're being multiplied to equal 12. Now, this term product means the answer to our multiplication problem. So in this case, our product was always 12. You got it, right? 12 is a product or an answer to a multiplication problem. Notice that if it were the answer to an addition problem, we call that a sum. The answer to a subtraction problem, we call that a difference, ding, 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 subtraction. You might have heard me say that before. And the answer to a division problem, do you know that one? That's a quotient. But for today, I want you to focus on the product, answering a multiplication. And then finally, factor pair. The two numbers together that multiply, those would be a factor pair. So 3 and 4 are the factor pair. That is great math vocabulary that we will be using for lessons to come as well as for the rest of your life. So keep those terms in mind. Your factors, your products, your factor pairs. Now I'm going to show you my favorite method for finding factors. Drum roll, please. The rainbow method. And I like it because it's mathematical and it's also beautiful. So let's start off with 12. If we wanted to list all the factors of 12, meaning the numbers that can multiply together to equal 12, well, we've just done that with our array. But I'm going to show you the different method for doing it. So what you want to do when you use the rainbow method is always start with 1. Say, is 1 a factor of 12? Yes, because 1's going to be a factor of every number, because 1 times 12 would equal 12. So you write 1 on one end, 12 on the other. Now you have to go in order. We just asked, is 1 a factor? Now we have to ask, is 2 a factor? Yeah, 12 is an even number. So 2 is a factor. What times 2 equals 12? 2 times 6 equals 12. Now we have to ask ourselves, is 3 a factor? Yeah, 3 is a factor because we know 3 times 4 equals 12. Now we're going in order. We just asked 3 a factor. So next we would ask, is 4 a factor? Yep, but we already have it. So that way we know we have found all factors of 12. I think of it like Pokemon when you say, gotta catch them all. Gotta catch them all. We did it. We got back to the beginning. Let's go ahead and try this with 20. So we're going to go in order. Is 1 a factor of 20? Yes, 1 will always be a factor. This is the easy one. 1 times 20 would equal 20. Now we ask ourselves, is 2 a factor? Yes. 2 times what? Do you know? 10. 2 times 10 would be 20. Then we ask ourselves, is 3 a factor? 3 a factor of 20. You could look at your multiples of 3, think about your multiples of 3. It's not going to be a factor. So then we have to skip that one, go to 4. Is 4 a factor of 20? Yes, 4 is a factor of 20. 4 times what? 4 times 5 gives us 20. Then we're going in order. Is 5 a factor? Yes, but we already have it. Got to catch them all. We did it. Oh, and I almost forgot to tell you why it's called the rainbow method. How could I forget? It's called the rainbow method because if you join your factor pairs, what does that look like to you? Beautiful rainbow. Let's do that for our factor pairs in 22. On your notes, you might even want to color these in. Join our factor pairs and you have a beautiful rainbow. Okay, I want you to pause the video and you try the rainbow method for 16. See if you can catch all those factors. Welcome back. Take a look for 16. See if you found all these factor pairs, 1 and 16, 2 and 8, and then 4 is a factor with itself, so I only wrote it once. And do you remember what you call that when a product is, it's the product of a number times itself, like 4 times 4? Do you remember what we call that special type of number? Say it with me on the count of 3. 1, 2, 3. A square number. 16 is one of those square numbers. Now, if you look on your math journal on page 39, so pause the video if you need to get there on page 39, it says write equations to help you find all the factor pairs of each number below. Use dot arrays if needed. Whenever we hear that word equations, we know it wants an equal sign. So these numbers might look familiar, 20 and 16, because we literally just did 20 and 16 moments ago. Did that on purpose because now we're just going to change the way we're writing our factors because this time it wants equations. So you could look back at your notes for your rainbow method for 20, and that's going to tell you all the possible equations we're going to have. So for instance, I'll have 1 times 20 equals 20. I need to write the turnaround fact, 20 times 1 equals 20. I'm just taking those factors and putting them into equations. 2 times 10 equals 20. 10 times 2 equals 20, right? And then I had 3 was not, 4 was, 4 times 5 equals 20, and 5 times 4 equals 20. So now when it asks the factor pairs, remember those were the two numbers together. So 1 and 20 are factor pair, 2 and 10, in this case, a factor pair of 20, and 4 and 5. So same idea, same vocabulary, it just wants you to write it a little bit differently. So I want you to pause the video and fill the table in your book out for 16 and 13, and then press play again to check your work. Okay, let's take a look at how we did with those equations. Check your work for 16. You can pause the video if you need to be able to see them all, that you got all, in this case, 1, 2, 3, 4, 5 possible equations. With 4, we didn't have to write the turnaround fact, right? Because it's the same thing, square number. And then for 13, you might have been saying to yourself, oh, this one was kind of boring, right? Its only factors were 1 and itself, 1 and 13. that actually has a special name called a prime number. 13 is a prime number. More on that vocabulary coming soon. But that one, you might have gone through and you said, is 2 a factor of 13? No. Is 3 a factor of 13? No. 4 a factor? 5? No. 6? No. 7? No. 8? No. 9? No. 10? No. 11? No. 12? No. 13? Yes, 13 was a factor. Oh, but we already had it. So this next question, how do you know it's at the bottom of page 39? How do you know you have found all the factor pairs for a number? Well, we're doing the same thing for each one. We're doing the rainbow method, but just writing, I did the rainbow method. That would not be a good mathematical explanation. We want to say it using math vocabulary that will make sense to anyone who reads it. So really, how you describe the steps you took, right? We start by asking, is 1 a factor? And then keep going through all the whole numbers until we got to a turnaround fact. Like in this case, we had to go all the way up to 13 to get to our turnaround fact. So let's put that. We start by asking if 1 is a factor, by asking if 1 is a factor, which it always is, right? Because 1 times itself will be. And then ask that for, oops, I'm having trouble writing here, sorry, hide that, for all whole numbers until we get a turnaround fact. So excellent job today figuring out factors, and good luck with the rest of your math work.